evening, sir.
Sir.
Yeah, good evening, everyone. Okay, so let's have. So I think almost everyone has joined. So which chapter we were doing in the last class? Yeah, we were doing, I think, combustion and flame, right?
Yes, sir.
Okay.
Sir, which chapter, sir?
Yes.
Which chapter, sir?
Pardon again.
Which chapter, sir?
We were doing combustion and flame. I think we were doing that chapter, and I think in 1 or 2 days we'll be starting with a new chapter. Just in 1 or 2 days we'll start with a new chapter. Let's continue today with combustion and flame. Okay. So in the last class we had done something about fire triangle also. Do you remember?
Yes, sir.
Yes. Just 1 minute. Okay, had I shared that with you with you people? Had I shared any PDF in the group? I don't think there is any PDF. Okay, just 1 minute. 1 minute. I'm just taking out.
Yes, sir. You have said about gravity.
Okay, combustion and flame. First we'll do combustion and flame. Then we will do gravity. Yeah, so here we were doing. Just let me share again. So combustion. Yeah, we did this fire triangle. In flammable substances, we were doing fire control. Fire control we were doing by using water. Drawbacks of water we did, like it can't be used for oil and electric fires. For the blanket can also be used as a fire control, but blanket can't be used on a large scale. If the fire is on a large scale, then you can't use a blanket. Carbon dioxide. So carbon dioxide is the best fire extinguisher. It creates a blanket over fire and cuts off air supply because it is heavier than air. So carbon dioxide expands quickly and brings down the temperature. So this helps in putting out fire. Extinguishing for carbon dioxide can be supplied in many of the following. So how the carbon dioxide fire extinguishers work? Okay. So the carbon dioxide fire extinguishers, they have different modes of working. There are different types of carbon dioxide fire extinguishers. Okay. So the different types of fire extinguishers, like in carbon dioxide fire extinguisher, one of them is pressurized cylinder. So in which the carbon dioxide gas will be filled under pressure. So when the nozzle is turned on, then carbon dioxide gas will be released through the nozzle. The second one is a soda acid fire extinguisher, where you use soda. So can anyone tell me the common name of soda, chemical name of soda?
Sodium bicarbonate.
Sodium bicarbonate.
Yeah, it's sodium bicarbonate. Very good. So soda is sodium bicarbonate. It is used with a small amount of acid. in fire extinguisher. So the reaction between soda and acid produces carbon dioxide gas.
Sir,
Yes.
bicarbonate means CO2, sir. Like that carbon dioxide. Sir. Bicarbonate means what? How can we
Why
write?
carbon?
Bicarbonate, how can we write that, sir?
What
It is not CO2. No.
I didn't get the question.
Like how can we write sodium bicarbonate, sir?
Sodium bicarbonate is formula is NaHCO3.
But
This
we
is
don't have hydrogen, no, sir.
where we don't have hydrogen. This is sodium bicarbonate, or it is also called as sodium hydrogen carbonate.
Yes, sir.
Okay, so
Like,
sodium bicarbonate or sodium hydrogen carbonate, both are the same. Okay, so this is generally in the form spray. You will get a foam of carbon dioxide gas. Okay, so a reaction between soda and acid will produce a foam. Okay, now see this one. Here you can see the foam spray cannot be used over electric shocks and not used over oil sprays. Can anyone think why we don't use soda acid fire extinguisher? See, the soda acid fire extinguisher, it is a foam spray fire extinguisher. So while the reaction with the reaction of soda and acid, you have the formation of water and carbon dioxide. Both are formed. Okay, so there will be some amount of water sprayed. So that is why it's not wise to use such fire extinguishers on electric fires. Okay. Then the third one is a dry powder. Like a lot of dry powder of chemicals like baking soda, sodium bicarbonate, or potassium bicarbonate is sprayed on burning substance. The dry powder makes carbon dioxide because of heat. So there is no reaction happening inside the cylinder when the dry powder is sprayed. So because of the heat, it changes to carbon dioxide. So hence, it is able to extinguish fire.
sir, like
Yeah.
because of the heat, why it produces heat? Like why it produces CO2, sir?
The reaction can be represented like this. You have sodium hydrogen carbonate. When heated, so when heated, this forms Na2CO3, sodium carbonate plus carbon dioxide plus water. Okay, so since here you have the formation of carbon dioxide just by heating sodium hydrogen carbonate. Got it? So we take the help of this reaction. We spray the sodium carbonate, and therefore carbon dioxide gas is formed over there. Now here we have the types of combustion, the different types of combustion. The first type of combustion is rapid combustion. When combustion happens at faster rate, it is called as a rapid combustion. Like petrol and gas, they show rapid combustion. They burn quickly. A spontaneous combustion is a combustion which starts on its own. Okay. So such reactions of the spontaneous combustion generally happens when the ignition temperature is very low or when the surrounding temperatures are very high. Then you can have spontaneous combustion. So a spontaneous combustion, a combustion starts on its own. See, a combustion starts on its own without an apparent cause. It is called spontaneous combustion. For example, coal dust in coal mines can start burning on its own. Since coal dust, they are not chemically bonded with each other. Okay, so coal dust means they are fine particles of coal, so that the carbon atoms are almost free. Okay, so free carbon atoms, they are reactive, and if they find out a small amount of oxygen and little bit of heat, so combustion will take place and it will start burning. Okay, also forest fires is a spontaneous most of the cases. Like in the summer seasons generally happens when the dry branches of trees they may rub with each other creating combustion. Okay. So that is a spontaneous combustion. For most of the forest fires which we see, we have spontaneous combustion. Then yellow phosphorus. Yellow phosphorus also shows spontaneous combustion. Yellow phosphorus when exposed to air, it burns quickly. It starts burning on its own. Then we have explosion. Yes.
So like the different types of phosphorus are like yellow, red,
Yeah,
white.
you have
So they
yellow
are like
phosphorus.
in those colors only.
Yeah, white phosphorus is also called as yellow phosphorus. They are the same. You have
Okay.
the red phosphorus, which is different. So in your matchstick, what is used?
The red phosphorus, sir.
Red phosphorus or yellow phosphorus?
Red phosphorus.
Yellow.
Okay. You just Google it and find it's yellow phosphorus. Okay. A mixture of yellow phosphorus is used so that just by a little bit of friction, it starts burning.
Sir, the yellow phosphorus is used in the plastic. You said that.
Used in plastic.
Sir, that example you said, like, just like in what
Matchstick,
yellow
not
phosphorus is used?
no, not plastic. Matchstick.
Matchstick. Okay, sir.
Yeah, for matchstick. Okay. Then the last one is explosion. When combustion reaction is so sudden that it releases a large amount of heat, light and sound, it is called explosion. So here rapid combustion is very fast like matchstick near a stone. Spontaneous combustion on its own. Examples are coal dust in coal mines, yellow phosphorus. You have forest fires. Most of the forest fires, they are all spontaneous combustion. Then you have explosion reactions. So explosion reactions, they are the reactions which generate a lot of heat and light, like firecrackers, bombs. They are all explosions.
Sir,
Yes.
I just now checked in Google, sir. It is red phosphorus. Sir.
Okay, it's red phosphorus. Check. Okay, anyways, I thought it was yellow phosphorus. Yeah, it's red phosphorus. Got it. So why red phosphorus is generally used? I think it's for their the red phosphorus has its ignition temperature a little lower, a little higher than the yellow phosphorus.
Sir, before it was used actually white phosphorus, uh, uh, then they found out that white phosphorus is the dangerous one, so that's why they changed it to red phosphorus
Yeah,
while
just one.
making.
Yes, sir. Yes, sir.
No, sir,
I saw
white
it in
phosphorus
Excellent.
is used for rat killing, no, sir.
Yeah, what happened?
Sir, white phosphorus is used for rat killing poisons and all those, no, sir.
I'm not sure. Okay, let's continue with the flame. The next topic is flame.
Sir, I have seen this in Dr. Banner, sir. White phosphorus is dangerous.
Which one?
White phosphorus, sir. That's why they
Yeah,
use
it's
red phosphorus.
white phosphorus is dangerous. It can burn on its own. Okay, so it is required to be kept in airtight containers. If you expose it to air, it will start burning. Now for the flame, So flame is basically, it is the region where the gases burn. So first of all, you will have the gases or the vapors being formed, and wherever those gases or vapors burn, that region is called as a flame. So here you can observe a candle flame, a lamp flame, or a Bunsen burner flame. So these are the three flames which have been shown: flames of a candle, flame of a kerosene lamp, and flame of a Bunsen burner. So the shape of these flames, they are almost the same. It is the visible and gaseous part of fire. It is a region where combustion or burning of gaseous substance. Yeah, Pranav.
Sir, like you have said that the shape of flame will be remaining same on or no, sir, why sir?
Yeah, the shape of the flame it depends on gravity.
Yes, sir, but why our gravity affects this flame, sir?
Because these are all gases. Okay, flame is the region where the gases are burning. So obviously gravity will affect the gases, as gas is a matter. So the shape in which the flame is formed, that is because of the gravity. Okay. The next one is, so I hope you have understood what's flame.
Sir,
Okay. So flame, it's the visible and gaseous part, a region where combustion or burning of gases takes place. So all gases which undergo combustion or burn, they produce a flame. So first of all, if there is any substance, it should turn into the gaseous state if it is a fuel. So a fuel which turns into the gaseous state will form a flame. Okay, or a fuel which burns in its gaseous state will form a flame. Those fuels which do not vaporize, they will not be forming flame. Rather, they will just glow. So structure of a flame, we had discussed this structure of flame earlier also. So every flame is divided into three zones or three parts. Okay, the outer zone of the flame, the middle zone of a flame, and the inner zone
Sir,
of the flame. Yes,
sir, is yellow color ideal for flame?
yellow color.
Ideal for flame.
I didn't get what do you mean by ideal. There is no ideal color for the flame. Okay. Okay. So the innermost zone of the flame, that is also called as the dark flame, dark part, as in that innermost part there is no combustion taking place. It's only the gases. So that is why it is called as the dark flame, dark part or the innermost zone, or it's also called as dark zone. Innermost zone, it is the least hot part of the flame. The temperatures are around 800 degrees centigrade. Then you have the middle zone of the flame, which is yellow. So middle zone of the flame, it is the luminous part of the flame. That means if we observe the flame, so the luminous part of the flame is middle zone. That is the part which produces light. So while if you observe in a candle you will observe a lot of the yellow zone is there. But if you observe the flame of your Bunsen burner, over there the yellow part of the flame is very less. Got it? So hence the visibility will be very less. It will not be luminous. It will not produce light. Rather, it will be producing heat. So it is the zone where partial combustion or incomplete combustion is occurring. Why can anyone tell why partial combustion or incomplete combustion occurs in the yellow flame?
Sir, because it is not exposed to much of the oxygen.
Yes, it is not exposed to much of oxygen. So hence, in the middle zone, there is less combustion or incomplete combustion. A
Sir,
complete, yes.
the surface area is covered by the outer layer of the flame, so it does not it does not like touch the oxygen, sir. It
Yeah,
does not touch with oxygen.
yes. So it doesn't combine with oxygen, it doesn't have sufficient amount of oxygen available, since most of the oxygen is utilized by the outer zone. Okay, so the outer zone is the non-luminous zone. It doesn't produce any heat, any light. It produces only heat. Okay, complete combustion takes place in the outermost zone. If any fuel is left uncombustible, if you observe that your flame is producing a lot of yellow and orangish flame, so that means your fuel is becoming, your fuel is not burning completely. If you are finding some dark particles being present, so it means your fuel is not burning properly. So see here, all the three zones of the flame have been shown. Outer zone of the flame, which shows the complete combustion, that's blue in color. The middle zone or of partial combustion, that's yellow in color. And the innermost zone, which is the unburned, just vapors. It's not burning, so it's the innermost zone. It's the least hot part. Got it? Okay. I just want all of you just to take a click of it or screenshot of it so that you can make a diagram of it.
Sir,
Yes.
the inner zone is also the coolest zone, right, sir?
Yeah, it's the coolest zone.
So we should draw this diagram.
Yeah, just don't draw it right now. You can take a screenshot and draw it later.
Done, sir.
So can you send this PDF in the WhatsApp?
Not possible to send in the WhatsApp. Maybe it will be possible to upload over there. Okay. So I will try to upload it. So then we'll be talking of the fuels. Okay, just give me 1 minute. I'm coming after having a glass of water. Just wait for 1 minute. Okay, now I'm back. So what substances do we call as fuels? Yeah. Which substances can be called as fuels? Yes, Pranav. Which substances can be called as fuels?
Sir, which are combustible.
Yeah, the substances which are combustible and generally they have a high calorific value.
Sir, petrol, sir.
Yeah, so their calorific value should be high. That means we should be able to use it as a fuel. Okay. So see, a material which is burnt to produce heat is called a fuel. So just let me check for those who are present. So Venkat Rudra. Venkat Rudra.
Yes, sir.
Okay, so tell me some examples of fuels.
Sir, LPG, CNG, petrol, kerosene, diesel.
Okay, tell me some examples of solid fuels.
Sir, wood,
Yes.
cow dung.
Okay.
Sir, and charcoal, coal, like that, sir.
Okay, very good. Zubair. Zubair. Zubair, are you there? Amatur Rahim.
Yes, sir.
Okay, Amatur, can you tell some examples of liquid fuels?
So kerosene, petrol, diesel.
Can you tell any other example of gaseous fuel which is not listed here?
Hmm.
Any one example of gaseous fuel which is not listed here?
Hmm.
Sir, I will tell sir.
Tasha, may I?
Ma'am, sir, Pranav.
Sir, LPG.
Sir,
Sir, LPG,
sir, CNG also, sir.
CNG?
PNG,
CNG.
LPG.
So hydrogen gas does it come under this?
Liquid nitrogen. Like,
The hydrogen gas.
natural gas.
Sir, natural gas, LPG, CNG, no.
CNG, LPG. Sir, if you're saying anything, your voice is not audible.
Sir, I also have an example, sir.
Sir is not in the class. You are the presenter.
Okay, so now am I audible? Pranav?
Yes, sir. Yes, sir. Yes,
Yeah.
sir. I also have an
Okay.
example, sir. A liquid fuel which
Okay.
is not present. Sir,
Okay,
ammonia,
okay.
sir.
Just tell the
Ammonia.
examples of liquid.
Ammonia, sir.
Ammonia. Do we use ammonia as a fuel?
Yes, sir.
LPG.
It
It's
can
the
be used.
hydrogen gas.
Yeah, hydrogen gas is used. I tell you. Okay. But I don't know whether ammonia is used as a. I haven't heard of using ammonia as a fuel.
Yes, sir. You can check
Okay.
in Google also. I have heard
Okay.
it.
Okay. Anyways, we'll end up the class right now. Okay, we'll end up and we'll from the next class we'll be starting after this. We'll start with the new chapter then.
Sir, methanol also,
Okay.
sir. Methanol.
Maybe ethanol. Yes, ethanol can also be used. It is
Sir, we have
okay.
discussed coal and
So by all
petroleum.
of you, yes,
Coal and
we have used
petroleum.
coal and
No, sir, I was asking
petroleum. We
coal
have
and
completed.
petroleum.
Coal and petroleum we have discussed, and
Okay, sir.
we will discuss it again. But let's do one more chapter. I think.
Sir, IIT.
Yes,
First,
sir.
we do one
Sir,
more.
now
Yes,
Sir,
sir.
I
Yes.
have a doubt, sir. I have a doubt.
Yeah. You just
Like,
ask.
like we have in calorific value, if we burn 1 kg of fuel, we will get a certain amount of energy, no, sir, from the fuel. So how is the energy come from the fuel, sir?
Pardon again.
Like in calorific value, when we
Chemical bonds.
yes, sir. When we heat 1 kg of the fuel, we will get the certain amount of energy, no, sir. Energy, sir, energy.
Yeah, so that amount of energy is obtained by the breaking of the chemical bonds and due to the formation of new bonds with oxygen.
Okay, sir. Okay, sir.